Hello everyone, this is Jade Xu at the University of Memphis. In this video, I'm going to show you how to run a repeated measure ANOVA analysis in which there's one independent variable that separates the entire sample into different groups. Here is the example. I modified an old example in which there are three measures taken on anxiety level for a group of patients before they started taking the medication, 1 week after they take the medication daily, and 2 weeks after the daily intake. I have gender as an independent variable because I want to find out whether the effect of the medication is the same for male and female patients. Here is how the data look like in SPSS. I have the ID number for each of the 10 participants. 5 of them are males and 5 of them are females. And the anxiety level before medication at week 1 and week 2 of the medication are in 5 different columns. I have 10 rows because I have 10 participants. To run the repeated measure ANOVA analysis, I go here, Analyze, General Linear Model, Repeated Measures, and you have a within subject factor name that given as factor 1. No need to change it. You can just specify how many times this factor has been measured. So that's the number of levels. Since we measured anxiety for 3 times, we put 3 here. And the measure name, whatever you want to call it, time, trials, treatment conditions, I'm going to call it time right here. Then you click define. Alright, here we know at time 1 our measure is the before medication. Time 2 is the medication anxiety measure at week 1, and time 3, that's the anxiety measure at 2 weeks after the medication. Here we need to put the independent variable into this place that's for between subject factors. You can make the design more complicated by having covariate. We're going to save this topic for later. At this point, we need to go to this place called Options, ask for descriptive statistics, estimate of effect size, as well as the test of homogeneity variance, since we have an independent variable in this study. In case that you need to do a pairwise comparison as post hoc for the factor, that's these 3 repeated trials, you just bring the factor to this place that display means for and ask for compare main effect. Okay, we can move on now, but I want also to show you it will be helpful to get a plot. This is called the interaction plot. I usually use the one variable that have fewer levels to separate lines, and the other variable put on the horizontal axis. Then you click Add, Continue. Okay, now we're ready to run the analysis. Just click on OK. So here is the output. The first couple tables are pretty simple. The first one just tell you you have, for the dependent variable, 3 repeated trials. And for the independent variable gender, you have 5 male and 5 females. And for each of the repeated measures, separate by male and female, your independent variable, you have the mean and the standard deviation and number of observations within that group. Since we have an independent variable to complicate the design, SPSS provides you this test of equality of covariance. This is one of the assumptions for repeated measure ANOVAs when you have independent variables involved. We don't have time to go to the details. Basically, we want the p-value, the sig value, to be greater than your alpha value. So we fail to reject the null hypothesis. In other words, we meet the assumption of equality of covariances. Okay. We don't really need to look at this multivariate test table. The next table is for another underlying assumption for repeated ANOVA, the sphericity. Again, this is a complicated assumption. All I want you to know is that when you have a p-value that's greater than alpha, you meet this particular assumption. Okay, since we meet this assumption of sphericity, in this table, the test of within subject effect, we are given 4 options, and the one we need to look at is the line that says sphericity assumed. So we have the error component right here. The sum square is 10, a degree of freedom is 16, with a mean square of 625. And factor 1 is the repeated measures. So for the 3 measures of anxiety, the total sum score is 113.267 with a degree of 2, and the ratio of 2 gave you the mean score. And for the F value, if you divide this mean score by the mean score of error, you get the F observed for this particular factor, the repeated measures. And if we want to look at, okay, does the effect of the medication vary for patients of the 2 genders? So we want to look at the interaction effect between gender and factor. Here is the part we look at. For the interaction effect, the sum score is only 2.067. And the degree of freedom is 2. The ratio between the 2 gave you the mean score. This mean score over the mean square of error, we have the F observed is 1.65. Since its p-value is 0.222, we fail to reject the null hypothesis. In other words, there's no significant interaction between gender and the factor. Remember that we also request interaction plot. Here, the plot shows you that at all 3 times the measures of anxiety was taken, a female patient has lower anxiety level than male patient, and the medication help both genders to reduce their level of anxiety over time, and the effect doesn't seem to vary significantly for the 2 genders. So the 2 lines appear to be almost parallel to each other. So with the test and the plot, we are comfortable to conclude that the effect of the medication appear to be the same for both genders, so there's no interaction effect between gender and the trials. Another question we can answer here is whether male and female patients are significantly different in their level of anxiety. So we go back to this table that's called test of between subject effect. Here, gender is the independent variable. And based on this particular test, we know that the average level of anxiety is not significantly different for male and female patient because the p-value is 0.058, which is greater than the alpha of 0.05 that we chose. One more thing that we need to do, remember that for the test of within subject effect, for factors, the 3 repeated measures, we found statistical significance, which means the average level of anxiety varies significantly at the 3 times when we took the measures. So when you figure out exactly which time is different from which time, that requires a post hoc pairwise comparison test. So we come here, remember we'll also request that in the output. So we come here, this part called estimated marginal means. This first gave you a table that's the descriptive information of the 3 groups. We look at the average level of anxiety at time 1, time 2, and time 3. And look at the difference. We can see that before the medication and at week 1, the difference between the 2 mean is 1.7, which is statistically significant. For the time before and week 2, the difference in average anxiety levels is 4.7, which is statistically significant. And at the end, for the measure taken at the first week, and the measure taken at the end of second week, week 2, the difference in average anxiety level is 3, which is statistically significant. So this tells us that the anxiety level for the 10 patients reduced significantly from time 1 to time 2 and also from time 2 to time 3. And the one last table that I want you to take a look at is the table we skipped. It's the Levens test of equality of variance. This basically tells you the variance of male-female patient measured at time 1 do not differ significantly. Same thing was found at time 2 and time 3. So we meet assumption of homogeneous variance in this data set. So just as a quick recap, we have tested 3 hypotheses here. For this first one, we reject the null hypothesis that the average anxiety levels are the same at time 1, time 2, and 3. And post hoc tests show that each pairs of the 3 times have significant difference in the average anxiety levels. And the medication helped to reduce the anxiety level from time 1 to time 2 and from time 2 to time 3. There's no significant gender differences in the average level of anxiety. And for the interaction effect, there's no significant interaction between gender and the trials on the measures of anxiety levels.